Hi, this is Bill for SparkyChannel.com. Today I'm going to show you how to install a combination switch and tamper resistant receptacle. These devices are very handy because where you would normally just have a switch, you can have your switch but also have a convenient receptacle as well. Therefore, it is a space-saving device. This circuit represents a kitchen circuit, and kitchen circuits now require both arc fault circuit interrupter protection and ground fault circuit interrupter protection. These codes can be found in NEC code 210.8 for the ground fault circuit interruption and 210.12 for the AFCI protection. Also, I have a video on this particular device, the AFCI GFCI device, and it goes over the code very carefully. Some of the highlights that you might want to know is that these receptacles must always be put on the first box in the circuit. They have to be labeled first outlet of branch circuit. The receptacle is labeled AFCI GFCI, so that's taken care of. Another thing that you need to know is that this cable that feeds this first box of the circuit must be unbroken from the main panel. That's all covered in 210.12 in your code book, and it's in my video as well that I'll put a link for in my video description. So this circuit consists of a receptacle that does provide the AFCI and GFCI protection, and then we're going to have a combination switch and receptacle, and then we're going to have a light. The circuit breaker is off, but the first thing we need to do is test our voltage detector to make sure it works properly. I'll test the voltage detector on a known live circuit, and you can see that this one is working properly. Once we have tested our voltage detector to make sure it's working properly, then we're going to ensure that the electricity is off. Just test all the different wires, and we see that there's no live wires in this circuit because the circuit breaker is indeed off. Before I get started with the installation, I'm going to do a quick test, and I have put Wago lever nuts on all of the wires for safety, and I have turned on the circuit breaker temporarily. And this is my electrician's meter. I'm going to turn the little backlight on, and I'm going to put one lead into the black wire and one to the white wire. And you see we've got 122.1 volts coming into the system. So we have excellent voltage coming into the system. Now, we can also test the ground. I'll take the lead out of the neutral and I'll put it in the ground wire. And we have 121.9 volts AC. So that shows us that we also have an excellent ground. We have excellent voltage coming into the box, and we have an excellent ground. Now I have turned off the circuit breaker, and I have removed the Wago lever nuts, and I'm going to do a quick test just to make sure that the electricity is off. I'll put my leads on the hot and the neutral that were showing 121 volts earlier, and we have 0.0. So the electricity is indeed off. Now I'm going to test for continuity, you see, because this is going to be a switch box as well as housing the receptacle, and this is the light box, and this is of course always covered by drywall. You can't see that there's a cable going to the light box, so sometimes it's best to do a quick continuity test. So I'm going to turn my meter to continuity right here, and I'm going to put one lead on the black wire here and one lead to the black wire here, and you hear we have a buzzer going off and we have 0 ohms. So this is continuous, and I can test it with the neutral wire, neutral and neutral. Okay, that's continuous, and ground and ground, that's continuous. So this is indeed the light box that is going to be served by this switch, and the electricity is once again off. Since this is the cable that brings the electrical energy into this box, it is called the line cable. and this specifically would be called a line wire. Since this cable right here is the one that is continuous by our test with the light box, this is called the load cable, and this specifically is called the load wire. So, and this light will be the load of this switch. So the first thing we're going to do is get all our grounds together. We have a ground that comes from the cable that's bringing electrical energy into the box. We have a ground that is going to the light box, and this ground here is a grounding pigtail. It is attached right in here with a screw to the box, and it bonds the box to the grounding system of the house. And I have a pigtail that is going to go to the device itself. To connect these grounds together, I'm going to use a 5 connector Woggle lever nut. Take your first connector and put it in the first slot and click down the lever. Then take the next one, put it in the next slot, and again click down the lever. And here we have a third one. Put it in the slot, click down the lever, and now I'll put in the pigtail that I made up for the device and click down the lever. Now push the grounds back into the back of the box, and we have a pigtail here ready for our device. You see, on the side with the short terminal, this is always your hot terminal. You turn it like this, and you have 2 black screws as well as the green grounding terminal. This screw is labeled common. So you put the line wire, we have determined that this is the line wire. You put the line wire to the common. That will take care of your electrical energy for both the switch and the receptacle. You see, this, if I connect it here to the common, there's a connector right here that connects these 2 terminals together. So if I put the hot wire here, both of the sides are hot. Okay, so I only need to put 1 hot wire to get both of these devices hot. Now, I have 2 neutrals, and I have 1 silver terminal on the other side and 1 bronze terminal. So I'm going to be connecting these 2 neutrals together with a Woggle lever nut and using a pigtail to serve this silver terminal. And that neutral wire, which will be connected to the silver terminal, will serve to provide a neutral for the receptacle. All the switch needs is the power coming in that's going to go to a common, and it'll serve both of the terminals, and then the load wire right here is going to go to the bronze terminal of the switch. So first we'll take the grounding pigtail and we'll put it around the green terminal in a clockwise manner, and then crimp it, and then we're going to tighten it down securely. Now let me make a point. Everything needs to be very, very secure. I mean, you always need to make very secure connections. But when your circuit has AFCI protection, it's extremely important that every connection be very secure, because this AFCI is looking for any kind of bad connection and it'll blow. Okay, so in order to prevent a lot of problems later on, make each connection very, very secure. Now we're going to hook up the neutrals. This is a 3 connector Woggle lever nut. I'm going to take 1 neutral and put it in the connector and flip down the lever, and then put the next neutral in there, flip down the lever, and then this is my pigtail that I've prepared, the neutral pigtail. I put it in there and flip down the lever. Now you can always check. You see on the back side, you can always see that each of your connections is excellent. You see, you put it in there and it's clear. You can see that they're in there all the way. Now put the neutrals back into the back of the box, and we're going to take the neutral and put it around the silver terminal in a clockwise manner, crimp it, and tighten it down securely. Okay, now we're going to hook up the hot wires. Remember, this is the line wire coming into the box. This is the load wire leaving the box going to the light. So this is the common terminal. It says common right there. I could put it on either one. It doesn't matter at all. Put it around the terminal in a clockwise manner. Crimp it. And tighten it down securely. Also, when you're working on these AFCI circuits, I really recommend this tip. This is a ECX tip. It's made by Milwaukee. It's patented. And see, it fits perfectly in the Leviton terminals. And to get your AFCI circuits working properly, everything needs to be tightened really well. Okay, this one just gets tightened down. So here is where the load wire goes for the switch. And this is our load wire that goes to the light. So we put it around the terminal in a clockwise manner. Tighten it down securely. I like to put the switch on top and the receptacle on the bottom. Now I'll put a couple wraps of black electrician's tape around the device for safety. Now you dress the wires. That is, you give them all their appropriate bends so that they push in kind of like an accordion, and tighten it up. When you wire the light, it's a simple matter of hooking up the grounds to the grounds, the neutrals to the neutrals, and the hots to the hots. Now I'll put the screwless wall plate cover on the device. Now I've turned the circuit breaker back on, and we'll test out the light, and it works just great. Turn it off, on, it works great. Okay, now we'll test out the receptacle. This is my Sperry Stop Shock receptacle tester. You plug it in, and it gets one green light, which is proper. And we press test, and it goes out. So the AFCI, GFCI controls this receptacle properly. Also, the AFCI, GFCI receptacle protects the switch and light. So our combination switch and tamper resistant receptacle has earned its AFCI protected outlet and GFCI protected outlet stickers. I'll put links in my video description for the Leviton combination switch and tamper resistant receptacle, as well as the Leviton AFCI and GFCI outlet. Also, I'll put links for the Fluke voltage detector, the Fluke 117 electrician's true RMS meter, for Wago lever nuts in the 2, 3, and 5 conductor sizes, as well as the multi-pack. I'll put a link for ideal grounding pigtails. Also, I'll put links for the Milwaukee 1000 volt insulated 3-piece screwdriver set, which includes the patented ECX driver. Thank you. I hope this video was helpful.